Hello, so since I'm out of town today, I'm posting this lecture for you. So here's our sort of final new type of derivation, um, which is called indirect derivation. So it's kind of like conditional derivation where you make an assumption and then if you're able to, it's got that thing where you kind of step into an imaginary world, right, and work out what'll happen, and then you can draw some conclusion and step back into the real world. Um, but instead of doing that to a conditional, it's a new sort of thing. So we're calling it indirect derivation. It's also sometimes called reductio ad absurdum or reduction to absurdity. It's used to show that something couldn't possibly be true, because if it were true, it would lead to an impossibility. And in logic world, an impossibility is a contradiction. There can never be a true contradiction, right? So what we do is we assume something to be true. We show this leads to a contradiction, and then we can safely assume that the thing we initially assumed is not true. It'll make more sense when we make it concretely. But, for example, this is done in mathematics all the time. If you've done proofs in geometry, you may have tried this sort of thing. People will, prove that there's no greatest prime number by first assuming that there is a greatest prime number and then deriving some sort of contradiction from it. So, for example, you might say like, I wonder if my wife is home already. Well, if my wife is home, then the porch light will be on, right? So let's assume that my wife is home. The porch light will be on, right? And then I get home and the porch light is off. Um, well, under that assumption that my wife is home, now we have a contradiction. The porch light is on and the porch light is off, right? That contradiction can't be true. So something must have been wrong with our initial assumption. It must actually be the case that my wife is not home yet, right? Something like that. So if we're doing an indirect derivation, we need to derive some kind of contradiction. And a contradiction is going to be two well-formed sentences where one has the form P and not P, and then we will combine those into a conjunction to make it very clear that it's P and not P. Right? So, that's clear enough, right? Not P is the contradiction of P, but of course, we can use more complicated statements, and as long as they're contradictory, those will count for an indirect derivation as well. So just because something has a negation in it doesn't mean it's necessarily a contradiction. So P and not Q, that is not a contradiction, right? Or, for example, the conditional P then Q and another conditional that is P then not Q, that wouldn't be a contradiction either, right? Because the negation is only of the consequent there. So here are some example of actual contradictions. P then Q and not, parentheses, P then Q, right? Not, parentheses, P then Q, and not, parentheses, P and Q, P then Q. Right? Any, contradiction is not just no negation and a negation, right? It can be one negation and two negations and three negations, right? Here we have the conditional, the third one here, P then not Q. So that can have a contradiction, but the contradiction would be not, parentheses, P then not Q, right? And so on. I will post these slides so that you can look at these a little more carefully if this is a little hard to see in video form. But hopefully you get the idea of what it is to contradict a statement, right? It's whatever the statement is, and then if it's a sort of a compound or a large one, you might have to throw that whole thing in parentheses and slap a negation outside of it. And that's what the contradiction statement is. So let's practice one real quickly. So let's suppose that we get 1, 2, 3 premises and this conclusion, right? So we're trying to prove Q, and we only have these 3 premises. Now, you may notice off the bat that a direct derivation isn't going to help us much because we don't have anything to feed into these conditionals, right? If we had not S, well, then Q would be easy with modus ponens, but all we've got is conditionals and nothing to sort of get them going to use a modus ponens or a modus tollens. So we're kind of stuck as far as direct derivations. And the other problem is that the conclusion is not a conditional, right? So I mean, maybe there would be a way to prove this with a kind of conditional derivation in the middle somewhere, but this is a good example of a time you might want to use indirect derivation. So here's how it works. We're trying to prove Q, right? So if you want to prove Q with an indirect derivation, you make an assumption, and the assumption is the negation of the thing you're trying to prove, right? Because what we're saying is, let's assume the thing I don't want to prove is true, and then we'll show that that creates a contradiction and must be false, right? And if the thing I don't want to prove is false, then the thing I want to prove is true. So we're trying to prove Q, right? So we're going to assume not Q. And now we get that for free, and that's helpful because now we have a little atomic statement. I mean, it's not really atomic, it's negated, but it's something we can use in MPs and MTs. So right away, I see that I could do a modus ponens with 1 and 4. I can get R on its own, right? And I'm just going to keep trying stuff. So now my goal here is not to get Q anymore, right? My goal is to get a contradiction. Any contradiction will work, right? So I'm going to just start trying to make moves and seeing if a contradiction falls out. So I've got R with 1 and 4 modus ponens. What else can I do? Well, is that a mistake? Crap. Sorry, I got confused for a second. So yeah, so our next move is 3 and 4 modus tollens, right? So I've got a not Q. That was my assumption here. And so I can do MT and get S. So I'm just kind of trying stuff here, right? Again, my goal is to get a contradiction. R and not R would work. S and not S would work. Q and not Q. Any contradiction will be fine, right? But so far I don't have one yet. So can I do anything else with what I've got here? Well, I can with 2 and 6, right? Modus ponens get not R. And now I have my contradiction, right? I have R on line 5. I have not R on line 7. Notice, you might say, what does R have to do with Q? I thought we were trying to prove Q. Yeah, it only has to do with Q in that we've managed to create a contradiction by assuming, again, the opposite of what we wanted to prove, right? So that's why R and not R matter. They just happen to be a contradiction. If we could have gotten S and not S, that would have been just as good, right? But now that we've got our contradiction, let's put them together on the line, make it very explicit, R and not R on line 8. And then we've done it, so now we can close out our indirect proof and conclude Q, 4 through 8 indirect derivation. And that was, again, what we were trying to prove, right? So we assumed the negation of what we were trying to prove, not Q, showed that not Q leads us to a contradiction, and if not Q leads us to a contradiction, then not Q is false. And to say not Q is false is to say that Q is true, right? So we've just proven Q is true by proving that its negation creates a contradiction. We'll try it one more time and see if that sort of cements in your brain a little bit. So again, when to use indirect derivation? I mean, if it's sort of obvious to you that you can kind of see a contradiction lurking in the premises, then that's a good clue. But it's not always obvious, right, that there's a contradiction there. So probably more often than not, you'll be using indirect derivation when you've tried direct derivation and it's just not working for you, and you don't see how conditional derivation is going to help. So sometimes indirect derivation is just like last resort. Well, another hint, though, is like actually anything that can be proven using this method, or I should say anything that can be proven in our whole logic, like all of our methods, can be proven with indirect derivation. So you could, if you wanted to, always start with indirect derivation. It's just not sometimes always the easiest way to do it. So you can kind of think of it as the last resort. It'll always get you there eventually. All right, let's do one more practice, and hopefully that'll help this method make sense. Do make sure to do the readings as well. That'll hopefully explain it as well. So we've got a few premises here, 4 premises and a conclusion. So the conclusion is not P then Q. Now notice this conclusion is not a conditional, right? The main operator is negation. So I can't do a conditional derivation on this one. Maybe I could try direct derivation for a while. I see some moves I could make. I see a modus tollens with line 2 and 3, right? Because line 3 is the negation of t, and the consequent on line 2 is a t. Feel free to do that, right? Try whatever you can. You can always, if you get stuck, pop into an indirect derivation at any point, right? There's no reason you have to start with it. But I'm going to go ahead and start with it just for the purposes of showing you how that would work. So, again, my conclusion that I'm trying to prove is not p then q. So for an indirect derivation, I'm going to assume the negation of that, which would be p then q, right? Now, another way of saying the negation of not p then q would be not p then q. I could assume that if I thought it would be helpful. I think that, just p then q is like easier to break up and use, so that's probably going to be a little more handy. All right, now, so I've made this assumption, I've got another premise to work with, and now my job is no longer to prove not p then q, right? My job is to find a contradiction, any contradiction. So I'm just going to start making moves and see if I can find a contradiction that'll pop out. Maybe I look at my premises and I see maybe a t and not t. Maybe I could get those on their own. If I could get p and not p on its own, or q and not q. I'm looking to find any contradiction. It's not obvious to me yet where it's going to come from. So I'm just going to make some moves and see if it'll start to appear to me. So first I mentioned I see a modus tollens that can happen with line 2 and 3. So I'll just go ahead and do that. That gives me not r then s. Is that useful? Well, that allows me to make a couple more moves. Look, so r then s is the consequent of line 1 and of line 4, right? So if I've got the negation on line 6, that's a couple modus tollens I could do there. So maybe I'll do those. So line 1 and 6 gives me p, right, with modus tollens. All right, I don't see any contradictions yet. I do see that line 5 and 7, I can do a modus ponens now, right? So that'll give me q. Still don't have any contradictions. But guess what? Line 4 and line 6, I could do a modus tollens, right? I have the negation of the consequent of line 4 sitting there on line 6, and that would give me the negation of the antecedent on line 4, which is not q, and that will get me my contradiction. 4, 6, modus tollens gives me not q. So I have q and not q. I've done it. All I have to do now is put them on the same line together, right? Make it an explicit contradiction, and now I can close out my indirect derivation, and I can conclude not p then q through 5 through 10 indirect derivation, right? So where people tend to get lost or confused is they'll be in their indirect derivation and they'll forget that their job is to find a contradiction, right? Because all of a sudden their job kind of doesn't seem like it has anything to do with the conclusion of the argument, the not p then q, right? Yeah, while you're in an indirect derivation, you're sort of on a whole nother task, which is to show any kind of contradiction, right? And then you can step back out of it and prove your conclusion. So here are a few indirect derivations in the Logic 2010 program. Although there are some slight differences in the syntax that they want from you with the indirect derivation, so maybe that's something better to walk through in person in class. But some of you seem like very ambitious and very comfortable with it, so if you want to get into it and just figure out the slight differences that they want from you as far as the commands, feel free to try these 1.003, 1.007, 1.013. I'm also going to post a homework, right? So you can just do these by hand, the way they are in the exams, the way I did them just now, and you may find that helpful as well. Feel free to email me if you get stuck or you have any problems, and we'll be back on class on Friday, and we'll walk through it as well. But I wanted to get you a start, since we're not in person on Wednesday, on the concept of the indirect derivation. Right? All right. I will see you Friday.